Okay. So can you hear me okay? Good, because sometimes it's a little low. Okay, so we will talk about specifically how we help customers to scale with LoRaWAN by providing the AWS IoT Core for LoRaWAN services, but also how we actually have a partner community that can help in addition to IoT Core for LoRaWAN to help customers, scale their products that they're building, their connected products, using LoRaWAN. And I want to start with a quote from Konstantin Berkuji. He's a sculptor, most renowned for his abstract sculptures that he has done, his work there. But he also had a lot of, interest in science and arts in general. But I think it encapsulates, very well what the problem with IoT in general is, right? Because IoT is very complex. You have a lot of different players. It typically takes a village to solve a use case. You have different hardware vendors, connectivity vendors, you have ISVs, SIs. So even though I'm fairly certain that Konstantin didn't think about IoT back then when he said that, I think I think it's a very nice summary of what we're trying to do, and that's what we'll try to talk about today. Is how can we help customers together with our partners to actually resolve that complexity. So in the way how we look at that in general is when I mentioned the village that you need to solve a problem. So what we have is a concept that we call edge to outcome value chain. It's a mouthful, but essentially what it means, if you're familiar with IoT, which I assume all of you are because you're here, we have different vendors and suppliers that are part of the whole IoT value chain. That includes edge to device, which is the hardware side of things actually. So it can be silicon providers. We have seen the ST Micro booth as well here, which is also ST is an AWS partner. That can also be OEMs that provide hardware. So hardware can be industrial PCs, it can be embedded systems, anything that's related to that, as well as ODM and CMs that actually build and design products. And then you have the connectivity piece. The connectivity piece can be MVNOs, MVNAs, on the cellular side. Obviously, it can be also partners like LNS operators that we all know, like the Things Network, for example. Actually is in the mix as well, and OrbiWise, which are also all partners or core wireless that actually provide the connectivity layer for the IoT application. And then last but not least, we have ISVs and SIs. So ISVs in our lingo are independent software vendors, essentially the companies that build the applications, that provide the inside, the cloud applications. And system integrators can do custom work for customers, specifically, custom design development work. Or consulting work, but they also work with the partner community overall. So an SI, for example, like a ClickerTech, can actually work with a connectivity partner to provide a solution that they're building for a customer. They integrate hardware from silicon providers like ST, or they use hardware from edge partners that provide finished products. So it's a very vibrant community that actually works up and down the entire value chain, and it's a very important piece, and that's what we're building. And that is, and finally also, that helps customers to resolve that complexity that I talked about, because then the customer doesn't have to go out and vet the technology, vet the vendors, work with all the vendors to find them. They can actually choose from a partner community that we have built for customers as well. So this is a bit of an eye chart. The point is also not all inclusive, so it gives you an idea of some of the partners that we're working with. And again, it's not inclusive as all, but just as an example of partners, when we talk about silicon partners, as I mentioned before, you can see them OEM, ODMs, and CMs. The connectivity partner side is on the right, ISVs, as well as the system integrators, which can be the big guys, like Accenture and Deloitte, but it can also as a number of regional integrators as well that we're also working with in the different regions and countries, so that can actually help customers as well. So another thing that we're doing when we looked at the chart that you saw there, obviously hardware is a very important piece, right? And if you look at AWS in general, you would say, well, hardware partners are relatively removed from AWS services, because they're a very important key ingredient, but they don't necessarily directly contribute to the service consumption, because that's actually done, on the cloud side. So if somebody is building, or you are building a solution on AWS, that actually, let's say, a predictive maintenance for electric motors solution, the software that has to be built to provide the insight to do the predictive maintenance is obviously what runs on AWS. But the hardware is obviously very much required, right? Because you need sensors, because otherwise you can't do any predictive maintenance for an electric motor. So what we do also to make that selection easier for customers as well as other partners, because that's what we also see what partners are doing, is working with other partners, as I mentioned. That's what we want to try to facilitate, is that we actually qualify hardware also. So what that means is we actually have test cases and test automation tools that those partners run, and they actually qualify then their device for a specific AWS IoT service. And there's a number of AWS IoT services, and most specifically, and Gaurev will talk more about that as well, AWS IoT Core for LoRaWAN as well. So there's gateway vendors in the catalog that we have that are specifically qualified for IoT Core for LoRaWAN. It's the typical vendors that you would also know from here: Dragino, Curlink, Tectelic, so examples, Multitech. And so that helps customers also to have the confidence that that device actually works with the AWS IoT services. It goes back to my initial point, resolving complexity, making it easier for customers and partners to actually pick the right hardware, so that actually their solution building can be accelerated, and it's less risky. So, and I also wanted to talk about a couple of use cases that are examples of what we have done with partners, and specifically also the multi-partner angle that I talked about. So again, if you look at the diagram that we had covered there, we had the hardware side on the left, the connectivity side in the middle, and the ISVs and SIs. In this case, the company is actually called QuEXT. So when we use the lingo that we looked at before, QuEXT would be the ISV in that chart that you have seen. So they actually provide a public safety platform, and they're specifically focusing on schools and businesses to prevent, prepare, and respond to emergencies. So as you can see, they have been well established. About 486,000 alerts and over 4,800 million messages have actually been exchanged for schools last year alone. So they help schools to recover from a lot of hundreds of critical safety threats. And what they did, they have an existing, like I said, digital safety platform, but they were looking at actually extending that by putting a new offer in place. So the offer specifically was here that they wanted to actually add a wireless panic button to the offering, right? So currently, everything they do is mostly on the back end. They can alert emergency response teams. They can, provide the dashboards that are required on mobile devices as well as on the cloud side. But this one was a very different engagement, because now you have QuEXT as an ISV, as a typical software vendor, to go out and provide hardware. So what they have done is they decided on LoRaWAN as a connectivity technology. So they actually worked with a value-added distributor, which is also a partner of ours, called CalShip Connect in the US. And CalShip, then also being a partner of AWS, worked with hardware partners to select the right hardware for QuEXT. So specifically, they work with layered connectivity on the gateway side. And then Radio Bridge is the provider, the vendor for the wireless panic button. Now, if you look at that from a use case perspective, this is supposed to go to schools, right? Schools are typically don't have an IT department. You do want them to actually be able to install it themselves. So, and again, QuEXT is not on the hardware, in the hardware business. They're on the digital safety platform side. So what they have done is actually work with CalShip as a fulfillment partner to deliver the solution. So what that means is so CalShip actually pre-provisions the gateway and the wireless panic button, and set up a SKU, a part number for QuEXT. So the schools can actually order that whole pre-provisioned kit for QuEXT kit from CalShip, and then actually just install it themselves. So a supervisor in a school can easily install it themselves and bring it online. And the interesting piece here is also that they have been able to do all this using IoT Core for LoRaWAN, which is our managed LNS offering that Gaurev will also talk more about on the technical side later, within 2 months from ideation to implementation. And that is a very short time frame. They were able to roll this out. And the interesting other aspect to it is also, yes, it does solve the wireless panic button aspect of the offering. But now if you imagine, now you have a LoRaWAN gateway in the school, or in a business for that matter, now you can also open up a lot of other use cases, because once you have a LoRaWAN gateway in the school or in a business, you can actually start looking at different use cases, right? So could you use the same LoRaWAN gateway, for example, for door alerts? Could you use the same LoRaWAN gateway, for example, in the cafeteria for cold chain or say, food safety and other things, So that is a very interesting aspect as well, because it would allow QUEXT Go to actually explore other business models, either through partnership or, out of their own organic approach to actually build that as well. So I think that's a very, 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 very strong example of how partners come together and solve actually a problem. And specifically here, also, of course, using LoRaWAN, IoT Core for LoRaWAN. And then the other example that I have is QUEXT IoT, very different. QUEXT is part of Madeira. So QUEXT actually is provides a smart home technology solutions that are specifically focusing on multi-tenant residential multifamily communities, right? So the idea is that the offering that QUEXT has, if you are a landlord, if you own multi-tenant assets and objects, you can actually use their offering to actually improve the value of your rental properties by actually providing technology upgrades that renters are looking for. So specifically what that means, which you can see here, the chart is a little bit small, but I think you get roughly the idea. So the QUEXT actually builds a thermostat, a smart thermostat. So that thermostat actually uses LoRaWAN network connectivity, and currently they're using a multi-tech gateway that is actually installed in that residential building, which is also, of course, as you can see, a qualified device. And so the thermostat is LoRaWAN connected. However, it also then, for the resident and the actual renter, it also provides smart home connectivity by offering Bluetooth, Zigbee, and Z-Wave also locally. So the idea is here that, as a renter, you can actually have all that technologies, all your personal gadgets, or, other systems that the rental property owner might install, also would be connected through that thermostat, which then acts as a LoRaWAN hub, so to speak. So I think that's a very interesting use case as well. And partners that were involved here specifically, it's like I said, multi-tech on the hardware side. QUEXT built their thermostat themselves, from a design perspective. But on the system integration side, again, we look at our edge to outcome value chain. You saw the system integrators on the right. We have a global system integrator, ClickerTech, actually, that helped QUEXT to actually build the infrastructure, on the LNS side, and then also is working on the transition to IoT Core for LoRaWAN. So that's a very nice example also from two different ends of the spectrum in terms of the use cases, how a LoRaWAN can be used, how the AWS services are being used, and how all of those partners that are part of the LoRaWAN community are also part of the AWS partner community. So, and then from a technical perspective, Gaurev will talk more about what is AWS IoT Core for LoRaWAN. That is one aspect of our presentation, and the other one also, when we talk about how do we work with partners. I mentioned Actility, I mentioned the Things Network, the Things Industries, or Orbywise, because we also support those LNS providers. So it's all part of a bigger LoRaWAN strategy that we have. It's not just focused on our IoT Core for LoRaWAN offering. There's also the partner offerings on the LNS side that we are supporting. And I will hand it over to Gaurev now. Thank you.
Thank you, Mike. So what is AWS IoT Core for LoRaWAN? So AWS IoT Core for LoRaWAN is a fully managed network server, a LoRaWAN network server that allows customers to connect their LoRaWAN-enabled devices to AWS services. It's completely serverless, so it is easy to set up the entire private network into your account, and then you can get qualified gateways and LoRaWAN-enabled devices to connect and build your own private network. And with this, because it's serverless, it's pay as you go, and then you don't have to maintain the infrastructure that is required for LNS. So AWS IoT Core is fully integrated with AWS IoT Core for LoRaWAN is fully integrated with AWS IoT Core. So under the hood, AWS IoT Core for LoRaWAN comprises of four components. One is AWS IoT Core itself, but the one that are shown here is cup server, the network server, and the join server. some of you already know the join server is the one that is used for device provisioning. So through join server, AWS IoT Core for LoRaWAN, customers can provision their devices. AWS IoT Core for LoRaWAN supports LoRaWAN specification 1.0x and 1.1. It supports class A, B, and C devices. It supports multicast FOTA and ABP and OTA provisioning. In terms of the gateway connectivity, the gateways connect to AWS IoT Core for LoRaWAN using basic station. The minimum protocol that is required is 204. For security, it uses X509 certificates. So all these gateways that connect to AWS IoT Core for LoRaWAN are qualified, that Mike mentioned earlier. So we have a device qualification program through which these gateways that supports basic station with 204 and above can be qualified. The QUEXT server not only just do gateway provisioning, but it can also be used for remote gateway updates. It can also be used for getting gateway statistics and updates from the gateway. So it once the gateway is connected, the devices that are already qualified for LoRaWAN can easily connect to AWS IoT Core for LoRaWAN, and the data will be integrated and will come to AWS IoT Rules Engine. Currently, we support 4 frequency plans, and in the 5 AWS regions. So each AWS region support all frequency plans that are listed here. It's US 902, EU, AS 9231, and AU 915. So a customer who has a very global footprint, for example, a customer who has a facility in US and Europe, doesn't need to build infrastructure in different AWS region. Because AWS region supports all frequency plan, they can actually build the infrastructure by connecting different gateways in different RF region into the same AWS infrastructure, so they don't have to replicate the vertical stack or the cloud application into different region. All of that can be integrated in only in one region. And we have some examples of these customers who have only one AWS region, and then they have coverage and they have use cases where their end customers are all over the world. Some of them are in US, Europe, and Asia Pac. We continuously take feedback from customers, and as we expand the RF frequency plan, and currently as I mentioned, we have 4, and then we are currently exploring more. In terms of the another use case, as some of you may know, Semtech LoRa Edge provides high extreme power saving capability because it does resolve location in the cloud instead of the device. It kind of blocks a lot of downlink. So the Semtech LoRa Cloud Locator was built using AWS IoT Core for LoRaWAN. As you can see here, uh, the device provisioning from the for the Semtech LoRa Cloud Locator, it has a join server where the devices can be provisioned using the AWS infrastructure. It uses dashboard and Lambda and then connect to the LoRa Cloud Edge server. Then from that, the devices, when they sends data, the GNSS lookup and the Wi-Fi lookup can happen directly into the cloud infrastructure. In that case, even the map uses the AWS location service. So the customer who's using Semtech LoRa Cloud, whether it's a reference architecture of Semtech or if it's a different architecture that you're using, the customers will be able to just see a dot on a map. And this is a use case where a customer can just get a certified or a qualified Semtech LoRa Cloud Locator device, use this infrastructure, deploy it either as a SaaS platform or in their or use the Semtech locator, and can directly see a dot in the map. And this works both for indoor as well as for outdoor. For indoor, it works using Wi-Fi scanning, and for outdoor, it uses GNSS. And as you might have seen, asset tracking is not for any one vertical. Asset tracking is used in agriculture where you have to monitor cattle. It is used indoor for monitoring assets when it enters the warehouse. It could be used for asset tracking when there's a fleet that crosses a different region. So asset tracking is one of the use cases that can encompass multiple verticals. This is an example how this Semtech LoRa Cloud Locator looks like. It has a different logo when it is using a GNSS versus Wi-Fi, and this is built using AWS services like AWS Lambda, Cognito for authentication, DynamoDB for storage. The customer can use and click on different field here on the locator to get the exact or the previous history of that asset. And this whole service is built using the serverless technology. There is no infrastructure to maintain, and it works for both indoor as well as outdoor tracking. Now, let me talk a little more about customers who are not using just AWS IoT Core for LoRaWAN, but can also be using other uh, providers' infrastructure, and how they can still build using AWS services. So in this, it may be a little small, but let me walk you through different uh, rows so you can think. So in terms of private networks, there are three broad categories. One is customers who want to build private networks and want to use AWS IoT Core for LoRaWAN as the fully managed network server. They can simply get the gateways, qualified gateways and devices, and they can connect to AWS IoT Core for LoRaWAN, from where they can just it's simply integrate with AWS services like DynamoDB, time series database, location. The second use case in private network is when then there are LNS that are built on AWS. These are partner LNS. Customer can buy the gateways uh, from the qualified gateways that are provided by the partner LNS providers. Get the devices that are qualified by the LoRaWAN or LoRa lines, and then they run a one-click cloud formation template. That one-click cloud formation template, which I'm going to talk shortly, integrates the LNS offering with AWS IoT. The only thing to remember here is instead of AWS IoT Core, it's AWS IoT Core. Instead of AWS IoT Core for LoRaWAN, it is AWS IoT Core, which integrates directly with all other services. There are 15 plus services that are integrated directly with AWS IoT Core. The third use case in private network is for the gateways. So gateways that support LNS itself. In that case, AWS IoT Greengrass can be used to decode the data directly on-prem, and then it can be integrated again with AWS IoT Core. So the offering is such the gateway providers provide the LNS directly on the gateway itself. It could be either the gateway providers or the network providers have some sort of an equipment that sits next to the gateway, but it's an on-prem solution which can still be utilized to build services directly on AWS IoT. Now, with regards to public networks, in case of public networks, the gateways are not managed by customers. Gateways are managed by the operator, devices are managed by the customers. In this case, the public network operators also run the one-click cloud formation template that integrates the offering or the SaaS platform directly to AWS IoT Core. Once the data is into AWS IoT Core, the customers can directly use other AWS services. Let me quickly talk about one-click integration. So what is this one-click integration? It's a simple one-click integration which uses CloudFormation template, and it establishes and provision all the services that are required between the network provider and AWS IoT Core. It it makes it seamless, and it is highly secure for bidirectional communication. It does the device management such that the devices can be added, deleted, or updated directly from AWS IoT Core towards the LNS provider. It also offers end-to-end encryption, and it can also be used for automatically updating the parameters that you get from LoRaWAN. into ThinkShadow, and all of this can be enabled through AWS Marketplace. Let me just quickly walk you through some of the offering. So in this case, this is Actility offering. So Actility offering is at AWS Marketplace. A customer can simply go into AWS Marketplace, click on Continue to subscribe. They can get a subscription into Actility. From Actility, they can buy the qualified gateway. They run the entire procedure, and within Actility, they can run a one-click integration. This is a diagram of one simple how one-click integration works. The customer doesn't need to know what exactly it is doing because it's already qualified for, and it has gone through the well architected secure framework from AWS. After that one click, the platform is directly integrated with AWS IoT. And this is another listing. Orbywise, likewise, customers can buy or subscribe to Orbywise, and with Orbywise, they can get a bidirectional data like what we get in Actility. One slight difference in Orbywise is for downlink, it has a mechanism to do both ACK, confirmed messages, unconfirmed messages, and it has built a mechanism where device uplink, downlink can be the acknowledgement can be used to build the additional infrastructure. It uses the same similar one-click CloudFormation template. ThinkStack. So ThinkStacks have two different offerings. One offering is where the entire ThinkStack can be installed into the customer account, and then within the customer account, it's directly integrated with the AWS IoT. The second offering is where customers subscribe to a SaaS platform on the ThinkStack, and with ThinkStack, then they can get with one-click integration. They get integration directly with AWS IoT. One advantage with the ThinkStack implementation is customer who need end-to-end security, they can keep the session keys, that is for the application session key, directly into AWS infrastructure. So it is not decrypted in the middle by the network provider. It gets decrypted only in the customer's account. And along with, like I mentioned, like there is a Greengrass based implementation that is also for on-prem location where there is limited connectivity, but still customers can utilize AWS IoT services. That was my last slide. Then, if you have any questions, please stop by. It won't we'll be right at the AWS booth.
Yeah, but 26B, but I'm sure you can
26, yeah.
the number. Okay, so
okay.
thank you very much.